We return to our problem involving the number of flyers a worker can hang on neighborhood doors dependent upon the number of hours worked. In this random sample of 12 workers, these were the results. The least squares regression line is y hat equals 1.07 plus 49.7x. We'd predict that a person working 6 hours would hang 299.5 flyers. Well, think about what happens when people walk through neighborhoods hanging flyers. It may be really hot or raining. One day they may get involved in a long conversation. There may be many factors then that cause variance, random fluctuation, in how many flyers can be hung. In our random sample, we observed a person work 6 hours that hung 330 flyers. A residual describes how far our observed y is from the predicted y. The residual is 330 minus 299.5, 30.5. Therefore, the person hung 30 flyers more than what was expected, a productive workday. Another worker in our sample hung only 270 flyers in 6 hours. Their residual is negative 29.5 flyers. This performance was below average for someone who worked 6 hours. Visually, we can see the observed points from which a least squares regression line was determined. Each point has a residual value, also known as an error term, because the observed y was off from the predicted y value of the LSR line. So there is error. But this error is really just random chance fluctuation. Recall from an earlier video that the results from many people who all work 6 hours will tend to follow a normal distribution. S is the sample standard deviation describing the random fluctuation of observed y values from what the LSR line would predict. Thus, S is the sample standard deviation of the residuals, or equivalently, the sample standard deviation of the error terms. Recall from the earlier video that if we knew the population standard deviation to be 20 flyers, then the random fluctuation of flyers delivered in 6 hours would follow a normal distribution with a mean of pretty much 300 flyers and a standard deviation of 20 flyers. In real life, we would not know sigma. The best we can do is calculate S, the standard deviation of residuals, from our sample. How far did our observed y values differ from the predicted y values? In our case, S is 21.1 flyers. Our estimate of how much fluctuation we'd have in 95% of our sample results would be within 42 flyers of the predicted y value, 2 standard deviations, whether we were at 6 hours or at, let's say, 4.5 hours. Therefore, as we use our linear model LSR line to predict in the future, we will expect random chance fluctuation. For a worker hanging flyers 5 hours, we would predict 249.75 flyers hung, pretty much 250, but the results will tend to fluctuate due to random chance from about 42 below to 42 above the prediction of 250 flyers. A single result of 223 flyers hung in 5 hours, for example, would not be terribly unusual. This person's residual would be negative 27 flyers. With sample standard deviation being 21 flyers, this would have a z-score of negative 1.29. 1.29 standard deviations below the expected number of flyers hung. Residual analysis will be important to us later in the course. Before we finish this introduction of residuals, we better discuss one more detail. The domain of x values in our sample was from 3 hours to 7 hours, and the chance fluctuation of S was also calculated within that interval. We are not to extrapolate beyond this interval in predicting flyers hung. For example, we are not allowed to use the linear model to predict flyers hung in a 10-hour shift because we have not observed any outcomes beyond 7 hours of work. If asked to predict flyers hung in 10 hours on an AP exam, we would need to respond that such a prediction would be unreliable due to extrapolation.